Welcome to a tutorial on fractions presented by the Regent University Math Tutoring Lab. In this tutorial, we will define a few key terms, learn how to find a common denominator, learn how to multiply and divide fractions, and learn how to add and subtract fractions. Here are the key terms we need to define. A numerator is the top number in a fraction. A denominator is the bottom number in a fraction. And an improper fraction is a fraction where the numerator is bigger than the denominator. Here's an example of an improper fraction. Now let's discuss how to find a common denominator. In order to directly compare, add, or subtract fractions, they need to have the same denominator, which we call their common denominator. Groups of fractions can have more than one common denominator, but we try to find the smallest one to make operating on them easier. To find a common denominator, we must first factor each number in our fractions. We need to do this for our denominators as well as our numerators. They must be factored down to their prime factors. These are numbers that can't get any smaller. Second, we find the combination of factors common to the denominators of all of our fractions. We will discuss how to do this in detail later. Third, we multiply each numerator and denominator by the common factors each fraction is missing in their own denominator. Let's look at an example where we have to find a common denominator. The fractions we are given are 1/3, 2/5, and 3/10. First, we must factor each number in each fraction. In this case, there is only one number that needs to be factored into a multiplication of prime numbers. That's the denominator of 10, which factors into 5 times 2. Next, we must find the common factors. In this case, they are 2, 3, and 5, because the denominators of each of the given fractions have at least one use of the numbers 2, 3, and 5. If any fraction had more than one use of these factors, we would have more than these three common factors. Now we can find the common denominator. The common denominator here is 2 times 3 times 5, which equals 30. Since we have the common denominator, we must now multiply each of the given fractions by its missing factors. In the fraction 1/3, we were missing the factors of 2 and 5, so we must multiply the numerator as well as the denominator by 2 and 5. In the fraction 2/5, we are missing the factors 2 and 3, so we must multiply the numbers 2 and 3 by the numerator and denominator of 2/5. The final fraction, 3 over 2 times 5, was only missing the factor of 3, so we have to multiply the numerator and denominator by only the factor of 3. The new fractions we have now are 10 over 30, 12 over 30, and 9 over 30. Note that with each one of the given fractions, the original value remains the same. The fractions still represent the same amount, but now they have a common denominator. Next, let's discuss the multiplication and division of fractions. To multiply fractions, we need to multiply all of the numerators and multiply all of the denominators. The product of our numerators is the answer's numerator, and the product of the denominators of all of our fractions is the answer's denominator. Dividing fractions follows similar steps to multiplication. To divide two fractions, we must first take the reciprocal of the right or bottom fraction, depending on how the division is displayed, and then use the steps for multiplying fractions. Whenever you multiply or divide fractions, be sure to reduce your answers to lowest terms. We do this by canceling factors shared by the answer's numerator and denominator. Let's do an example of dividing fractions. The problem given to us is 14 over 25 divided by 21 over 20. This is called a complex fraction and can also be represented as two fractions side by side with a division sign in between. To divide, first we must find the reciprocal of the right or bottom fraction. To find this, we must simply flip the fraction so that we now have 20 over 21. After this step, we can use the same process used in multiplication to solve this problem. In this example, we are multiplying 14 over 25 with 20 over 21, which results in 280 over 525, because 14 times 20 is 280, and 25 times 21 is 525. The next step here is to reduce this fraction to its lowest term. This can be done by eliminating its common factors, by factoring the numerator and denominator and eliminating those factors that they share. The numerator factors into 2 times 2 times 2 times 5 times 7. We get this by asking what the smallest number is that divides the numerator. The first 3 times we asked this question, this number is 2. And after that, the numbers are 5 and 7. When we get to 7, we know we're done because it's a prime number. The same must be done for the denominator, which factors into 3 times 5 times 5 times 7. Note that the numerator and denominator share the factors 5 and 7. Because they are shared, we can cancel them. After multiplying the remaining factors, we get our new fraction, which is 8 over 15. And now we can't do anything with this because 8 and 15 don't share any common factors. Now let's discuss addition and subtraction of fractions. To add or subtract fractions, first find a common denominator between all fractions. Once we have the common denominator, we must add or subtract the numerators. Be careful for negative fractions though. To subtract the negative fraction, we need to add the positive version of that fraction. And to add a negative fraction, we need to subtract the positive version of that fraction. Finally, remember to reduce the fraction to lowest terms by canceling factors shared by the numerator and denominator of our answer. This must only be done when we have a common factor. Sometimes we don't have common factors, and therefore we can't cancel anything in our answer. Let's do an example of subtracting fractions. We're going to subtract 12 over 30 and negative 9 over 30 from 10 over 30. The first step is always to find the common denominator. Since we already have a common denominator from earlier, we can go straight to the subtraction. Since the denominator is the same, we can put all 3 numerators and their operation signs on top of our 30. Notice that we have a negative 9 in this problem. To subtract the negative 9, we must add a positive 9. This gives us 10 minus 12 plus 9, which results in 7. So the answer is 7 over 30. Now 7 is a prime number, so we can't reduce it. And we know the factors of 30 are 2, 3, and 5, as we found out earlier. Because there are no shared factors between the denominator and the numerator here, we cannot reduce this fraction to lower terms. Thank you for taking the time to learn about fractions and for making the most of your Regent experience.